Hello everyone, welcome to Mindcat Beam Cafe. And in this session I would like to discuss about how to work with the Tekla Structural Designer and Autodesk Revit. By the way, my name is Ong, and in this session I would like to break down into 4 parts. One would be introduction, then second would be requirements, and third would be workflow, and the last would be the conclusion. The first, introduction, and actually interoperability is the most important part of being for structure, actually not only for structure, even for the rest also. So this process can increase the productivity for the project, so we can minimize a lot of repetitions on both sides. Both sides mean either engineering design sides or design modeling side. Then so that we can improve the collaboration between the analysis design process and drawing detailing process as well. And additionally, we can minimize, not eliminate, but we can minimize the amount of information drop at every stage of the project development. So come to the requirements. Then we need to have analysis tools, we need to have the ordering tool, and some add-in as well. So for analysis tool, I will be using Tekla Structural Designer 2018, and for ordering tool I will be using Autodesk Revit 2017, and we need to have the add-in called integrator for TSD. The one can make the communication between TSD and Revit as well. And additionally, we need the Dynamo add-in, which is kind of virtual programming add-in. The one is good for Revit to speed up their or maybe our productivity as well. Then second thing is the preparation. Come to the preparation, we should have the Revit standard templates, we should have the Revit standard library as well. And the library, we should have the kind of shape parameter and kind of structural columns and structural framing as well. And finally, we need to have some Dynamo code to improve or to increase our productivity. Come to the workflow. As being for structural, we have basically 2 options to go. One is we start from the authoring tools like Revit or Tekla, or like kind of modeling software. From the modeling software, we will create the project first. Later on, we use add-in to transfer information to the analysis software like TSD or Step Pro or ETAP, something like that. But that option 1 process, I found out it's a lot of lagging information, especially from Revit to either TSD or ETAPs or Step Pro. We cannot export out the slab as well. Then some other kind of limitation as well. So in this process, I choose to create a project in analysis software first. Like in this case, I'll be creating the model in TSD. Then later on, we will transfer information to the Revit, and we will proceed the rest of the documentations or those kind of modeling stuff. I mean, from the documentations or submission, that kind of purpose, that we will proceed it. So okay, now we jump over to the TSD. Okay, this is the Tekla Structural Designer 2018. Then I already have the 3-story RC building. So this is the foundation level. This is the first story, second story, third story, and roof slab. Then we have the some area. This area is actually be the garage area. I try to offset down 600 offset down from the main floor, and this is the entrance veranda, also 100 offset from the main floor, and the rest veranda also same thing, 100 offset from the main floor. And even toilet and bathroom also I try to offset this floor level 100 offset from the main level. Okay, then this model is already considered as already finished the design, or maybe they have finished some point of design stage, so that the column size already been decided, beam size already been decided, and even the reinforcement also applied. So here we can see the reinforcement information. Okay, some information is missing, I think. Okay, I will rerun it and see it. Okay, I will rerun over here and we see how. Okay, looks okay. Some beams are warning. Okay, they may have some issue. Okay, we just ignore it. Our scope is to interoperate between the TSD and Revit. So regarding with the structural analysis and design parts, we just put aside. And we go back to the model, and you will see the column again. Then right click and check the interactive design. Then now okay, ready. So the column size already been fixed, then rebar also already been fixed. Even same thing on the beam also. So when we select the beam, one of the beam, right click and we check the interactive design status. Yeah, so here it is, all the beams. I think reinforcement already been decided. So we consider as this model is ready to export to Revit. So what we need to do is go to the ribbon and go to the home tab, then under beam integration, then we can see the Autodesk Revit export. Just click. The first one is to define the model location, so we just leave it as there 0,0 this point, the origin point to be x0, y0, z0, and rotation also 0 degree. Just leave it that way and click next. Then this time we have to decide which element we're going to bring. So our case, we will bring all the element except analysis results. We don't need it that in Revit, so we leave it as unchecked and click next. Then this time we're going to map the material grade. So okay, we leave it as grade C32/40. It's okay, then click next. Then now this point of time we have to decide that this is the first time export or this is the second time update on the existing model or not. Our case is this is the first time to export, so that we choose the first option. Then we have to find the place to save the exported neutral file. You can save it. So we make it as TSD to Rvt. The one is RC structure. You okay, just leave it as 01. Then just save. This file will be saved as .cxl format. So just save it, then finish. So now we are done in TSD part. So we have to go back to the slides. So now what we're going to do is we're going to launch the Revit. So go to launch the Revit. So this is the Revit 2017.2. Then what we need to do is we have to open one template file. So if we have the proper template file, that would be great. So for my case, I will create new, then I'm going to looking for my template file, which is located at over here under E drive. Okay, this is the place where I save the file. Then this is the template file. I try to prepare some common things inside that template file, so I'll open it that and click OK. Okay, now this is the file that I opened using my template file. So I'm going to save this file as a project, so click and save it. So this one I call it as TSD. So we can say that Revit RVT. Okay, VT from TSD, and this is the RC structure 01. Say that. Then we go to options and maximum backup to be keep it as 1. Well, so I don't need too much backup, so let it be, then save. Okay, in this template file, what we can have is that those necessary schedules and some legends and some line types are already been set up. So okay, so now what we're going to do is we have to bring the TSD exported file into the Revit. So go to the Tekla integration tab. Then we have to click this to integrator for structural designer. Click that. Okay, so oops. Okay, this is the first page. So this integrator is for the Revit 2017. Then this is the some kind of description. So go to click next. Then okay, now we are going to import model into the Revit. This is the first time, so we choose the first time export, then click next. Now we go and look for a file, neutral format that I saved earlier. So it is here. I exchange, then select this, open, then next. Now we have to decide which element to be bring to the Revit. So our case, we will check all of it, then click next. Okay, so now here what we can do is we have to map the elements from the TSD and from the Revit. So over here we just click this first. Oh sorry, not this. Let me see. I think is we what we need to do is we clear it off, and we have to check the review map, then click next. So the next page we're going to have a chance to map the elements between two platforms. So this element coming from the TSD and this is from the Revit. So what we can do is we have to click override, because I already have the family. I already saved over here, so I'll be using this family, not the family that application path. So what we need to do is remove this one, then we have to add the family. Our case, this one all are rectangular, so I will choose this family to bring it in, then click OK. So now when you expand it, you see that this size they were created. So now come to the next. So application allow us to save the this mapping.xml file. So I make it as like, I'll put a TL in front, so means this mapping file is owned by me, for example. Save, then click next. Sorry, then this is the framing, also same thing, we have to click to override. So the current one, the default one, is the Revit default family that I don't like it, so I remove it. Then I will add my own. One is under here, then rectangular beam. We will put a rectangular beam first, and click OK, then click next. Okay, this time also allow us to save this mapping file. Okay, I will save it there so that I can use it next time. Save. Then now time to map the material. This C32/40 come from the TSD. So in Revit we have to map with the material that I already have it. So in Revit we don't consider as the grade or whatever. This structure is the concrete structure, so I just use the cast in situ. Then click OK. And if I need to classify the concrete grade in future, then I will do in separate way in Revit. Then now finish. This one also same thing. I will save this one, this mapping file, save it. Now application is now start to import the elements. Just wait a while and see it. Okay, so now TSD model already been imported into the Revit. Okay, so now this is the summary. As long as we didn't see any message over here, means our transferring process is considered as successful. Okay, close it. Then what we need to do is we have to switch off the analytical line, then we have to change to shaded mode. Oops. Then you see it. Okay, so now it looks not so good, so I will change a bit on the graphic display. Okay, so apply. Okay, so it looks better. Okay. Okay, now we have to take a look to the model. This is the Revit model, and this is the TSD model. In TSD model, all the column position, beam positions, and alignments are okay in Revit. Oops, sorry. Only the difference is the slab location is not follow. So what we need to do is we have to bring down manually. So in my case, I'm a lazy guy, so I try to use Dynamo code to bring it down. If things are small, then we can select the flow, and we have to key in, write down, for example, like minus 600, 600, then apply, then the rest also we have to do same process. So I don't want to do that, so I will be using the Dynamo code to run. So click Dynamo player to use Dynamo player. So the requirement is that Revit should be at least version 2017.2, and Dynamo version also should be higher than 1 point something. So currently I'm using 1.3.3. Okay, so what we're going to do is we go and path the location of the code where I save. So these are the code that I'll be using for this process. The first one is to set the the slab aligned to the beam elevation. So I will use this code to run. This code mainly is to find the beam offset, then this offset value will apply to the slab. Okay, so here, so the first thing is we have to select the beam so that we can have the offset value. Then later on we have to select the flow. Our case only one flow, so select one, then finish, then set, so that the slab will automatically align to the top of the beam. So the next thing is the rest, this veranda and twilight drop. So to do that, run this code again. Then this time select the beam. So just select one beam will do. This is 100 drop from the main flow. Then come to the selections of flow. Then we have to select more than one. Select the flow. Okay, then come to here. Twilight is the same thing. Then after finish selecting the flow, then we click finish. Then set value. Okay, now we are done modifying something. Okay, but we have to take note that next time when we update the model, then those slab will be bring up again. So yeah, bear in mind that. Now come to the column. This column, no choice, select, then top offset we just bring it down by 100. Just bring it down. Okay, looks fine. Okay, so now this Dynamo just put aside first. We have to look into each element properties. So select the column, then we can see that this column information, like those information from the TSD come along with it, like a rebar and rebar cover as well, and rebar this column marking as well. Is the material and some kind of information also. For our case, we have our own parameter to provide the rebar, because my schedule is already been set up based on the parameter that I created. So okay, what we need to do is we have to transfer those information come along with the imported model, then we transfer to our rebar location. I mean, like this rebar information will be placed over here. Then another thing is, when information comes from TSD not only provide the reinforcement size and quantity, even provide the marking also. As a consultant, we don't need this marking. We don't need this marking also. This marking is a bit unusual. What we do is, for example, like this link will be H8 or H10 150. 150 is the spacing. H8 or H10 or H13 is the bar size. So 49 is actually be the link shape types. This one is mainly for the fabricator. As a consultant, we don't need to do this information we have to remove it. If we remove manually, then it will be quite tough, so that I'll be using code to run it. I will show it later. So now we go and check the beam again. Beam also same thing. Beam information will become in that way. This is the bottom bar. So bottom bar C means center, 2H13 means H13 rebar, 2 rebar. Then behind just 36 is the bar. It's kind of bar type. Some are L shape, some are some kind of length. Based on the length, based on the shape, then TSD already define it. But as a structural consultant, so we don't need that far. So we have our own schedule is like that. for beam schedule is something like that. We have a beam marking, we have a beam size and beam span and span types, and the rest will be top left, top middle, top right, bottom left, bottom middle, bottom right, something like that. We don't need the types, so what we need to do is we have to remove those unnecessary information. The another thing is come to the top bar, also same thing. They just put a top bar and left, center, right, all in one information. So as a consultant, we need to split into three: top left, top center, or top middle, and top right. So we have to split. So that kind of process, if we do manually, then it's really very tough. And some more, they provide the percentage also. So this percentage also we don't need it, so we will remove it away. We will put it fully. Okay. So then other thing is beam marking also come along with the model. So you can see that over here, this is a part marking. We call it as a beam marking. This marking also we have to reflect on our Revit beam marking as well. Okay, so now what we need to do is we have to save this file first, then go to the column first. This is a column. Then what we need to do is go back to my Dynamo, and I will run the set column reinforcement. What we need to do is just click run. Then things will automatically appear. Actually, it's not automatically appear. What application do is that those rebar information from the TSD we transfer to our Revit parameter. So whenever model is updated from the TSD, then they will give it to us as a .clx, I think CLX file, CLX or CXL, yeah, .cxl file. Then what we need to do is we have to rerun the code to update our information, Revit information. So this is the way that we do. Okay, so now here another thing is, I think before we do, we need to remove the level 2 actually. So I think this level 2 we don't need it. Delete away. If we remove, if we delete away, then what happened? We see it. I think we only need level 1. This level 1 also not, we are not saying level 1. We say this one as a base, or maybe top of footings or top of parquet. You can say that. Then okay, now what happened is here is shorten it. So what we need to do is we have to bring this again. So this time we don't do import, we will update. What we will update is only the column, because this column now shorten it, the rest are not. So what we need to do is go to the TSD, then integrator, then okay, next again. This time will be update. Okay, yes. Select the file where we save. Okay, here we go. Select this one, and next. This time we don't bring grid, level, slab, only member then we bring. Okay, then wall currently don't have, but stay, we just keep it, no problem. Next, then we already map it, so we don't need to worry about it, just finish will do. Okay, things are back, and you see that this 3 column location change. This is kind of information that this add-in will provide, which elements are already changed, then they will notify us. Okay, it's good. Then this column, no choice, we have to bring it down. Okay, so now what we're going to do is that we go back to the column schedule. Okay, then what we need to do is we have to run our code again. Whenever we update the model, then we have to run this code. Then now here we are. So we have the column. So this column also C20 means like when you select the column, for example this column is C27, for example this is the first column base to level 1, so they put it C27 1, so with C27 2, C27 3, C27 4. So in our case we all make it all as a C20, it's 27. So sorry, not Tekla, this is the column up here, it's a C27. This C27 is actually appear on our column schedule. So yeah, this is it. Then now we go to the beam schedule, also same thing. Currently it's empty because of the beam information haven't transferred from TSD information to our Revit information. This is the Revit information. So what we need to do is we have to run the set beam reinforce code. Okay, done. Then go and see the beam schedule. Then there we are, it's already been done. Then what we need to do is we have to format something like all the rebar. We try to make it at the middle, and the rest are as it is. Then now what we need to do is, okay, over here whatever reinforcement from the TSD we try to split into top, center and right. It's okay already, but one thing is that those prefix L, C, R is stay there, so we have to remove it. So what we need to do is run the code to remove it. So easy. Okay, then whatever blank information we may not know because some are decided by the engineer. So what we need to do is this table we will export out to Excel and let engineer to check it out. Is that what they need, or they want to add up information over here, or they want to add just dash over there? Let them decide. Then after that we will bring back that information from Excel as well. Okay, so this is the basics workflow, I mean the simple workflow between the TSD and the Revit. So now, okay, we have done something over here. Then same thing, come to the view. What we need to do is go to view, then structural plan, then we have to create 4, level 1, level 2, level 3 and roof. So regarding with the level 1, so this is the level 1 view. Okay, how come it's a roof, sorry. Okay, this is the level 1 view, for example. So we went to apply with the view template that I have it, so I just click apply, then concrete framing, then applied. Okay, then there we are, it's already been settled. Only what we need to do is we have to do some tagging over there and dimensions over there. Then yeah, then we do our drafting and production process. So at the same time, engineer side also they will updating their model based on some reason. Then for example like this column, they want to increase, for example increase to like rather than 250 by 250, then they want to change to, for example 350. Then what we need here, change it 350, sorry, not 350. And even this column, also a whole column, they will change it to 350, for example 350. Okay, come to here, then change to 350. Then some beam they will update, for example like okay, this beam I think its current beam depth is not enough, so they will change to 200 by 700, for example. So okay, these changes happen, the flow they don't change, then yeah, that's it. Then they will save it, then they will rerun the design analysis. So it's already finished the analysis. So what they need to do is to export back to Revit again. Click there, the next. Then this time we don't bring the grid information, step information that we don't want, wall don't want, foundation don't want. We only bring the member. Member means columns and beam. Then click next. We do material, leave it that way. This time update, we will update it. Then select. Then we override it. If we want this one as a backup, then we just back up somewhere else. Then we will override on this and save it. Then this update, so just click finish. Then we are done on the TSD part. So we go back to the Revit. So we will see that after we change the beam size, some warning appear. This may have some issue because of maybe some reason. Right click and see it. Then check the member, for example. Okay, they may have some issue. Issue is about the slenderness ratio. Yeah, because of the beam depth increase. Because of that, then this beam is become, it's supposed to be H and B ratio supposed to be bigger than 2.5. Then our value is now maybe lesser than 3.5, lesser than 2.5. That's why this one appear. So this beam supposed to provide supposed to be designed as the D beam. Yeah, so okay, that one let engineer to redesign. I mean, they will change the rebars, or they will provide more links or something. For our case, we back to Revit, and what we need to do is we go and update. So go to integrator, then we have to update and select the file, and next. So we only will bring the member because the changes is only happen at the member. So next we do, so stay okay, finish next. So we can see that the columns will be extended. Okay, column size. Okay, over here the changes is beam size change, beam size change, beam size change. Okay, why column size didn't change? I already changed the column size and didn't change. Okay, column size didn't change. Okay, something wrong here. I have to go back to the TSD. Column size already changed. Yeah, column size changed, right? 350. Okay, so save. I will export. Export on it and come to the Revit. When we import, then we need to see the mapping. See the mapping. So next, select that one. Next, come to here. I think it's column, beam, material. We don't need to review. Okay, we will review the column, then expand it. Because of this we already changed to 350 by 350 because current map is only 250 by 250 because the type is not available over here yet. Maybe that's why. So I cancel first. Then what we need to do is over here under family, then I have to provide the type for it. Where is the column here? First time they create themselves, second time why they don't create themselves, not sure. Okay, I will duplicate it, then I will give the name as 300 and 300, then to change the size as well, 300 and see. Okay, let's save first. Save. Currently this one is 250. Okay, so now we go and import again. So before we import, we make sure to check what new size already been introduced. so those size should be available in our project as well. Okay, this one, next, we have to review it, then next, expand it. Now you see the size, if they have the same size then they automatically map it, unless they won't. So next, come to the beam also, you have to check it. 700, oh, you see here 700 is not, because we don't have a 700, so they try to pick the nearest one. So same thing, we cancel it again. So we have to create this size, 700 size over here as well. This two size we don't need it, we throw it away. Then from here, duplicate it, then put it in 700, then size change it to 700. Okay, then we save, then we update again, come to here, oops, sorry, come on. Okay, so next, update, choose the file, then next again, make sure to see the map review. Okay, this one good, then next again, see this one also now is okay, ready, then finish. So now column also okay, now we see here the full picture, like 1 2 3 4 5 6, all the column means they count one piece as one column. So we have a few column updated. Then even beam, okay, this time is only columns updated. So let's see here, column is already been updated. Then what happened is that we have to run the code to get the update information into our Revit properties. So set column reinforcement again, then set beam reinforcement again, then the prefix, then after that we go and check our schedule is okay or not. Okay, beam schedule, see here now is settled. Then only column size is not there yet, no problem. Beam also same thing, beam size is not there yet. This is because of the family type, because this is the type mark. So go to the family, then come to the column, right? We have to do it, what we need to do is double click on it, come to the type mark, then we have to key in manually. This one also can be done with the code as well. So for this case, just type it in first. Then this one is the same thing, just type it in 350, 350, apply. Beam also same thing. Okay, right, after we change, or maybe we change over, we type over here also fine. 250 times 500. I think it's not so sure, so cancel it. I think we better change here. So 250 times 500, apply it, okay. Then all 250 by 500 will appear. Then 250 by 600, same thing, 250 by 600, okay. 250 by 700, 250 by 700, okay. 250 by 750, line, okay. Then 250 by 850, then apply, okay. Then now we get the full picture already. Some sidebar, if sidebar is already provided, then things will appear, unless all will be blank. Come to the column, also we have two schedule. One is type mark schedule, another one is type mark schedule. Type mark schedule also same thing. Column size doesn't appear because of maybe some filter is over here. Let me check what filter currently using. Filter is not using. column type also. Oh, okay, column type mark currently we haven't put it in yet. So the column type mark should be same as the type mark. Okay, never mind. This one just forget it first, because we don't have the column type mark information in the element at the in the element property yet. See, this type mark is not there yet. That's why the thing doesn't appear. Okay, anyway, so this is the way that we can improve our productivity in Revit, and not only in Revit, even, you know, yeah, especially in Revit, you can say that, because engineer will start to create their model, then later on they will pass to us, even partially also okay, then later on they will go and proceed the improvements or development. After they finish, they will give us, then we will update. So direction, like kind of information transition, it's not the bi-direction. It's one direction. After finish, then update. After finish, then update. So have to be that way, then would be great, because if we update information from Revit to TSD, then some point some structural types like release types or something related to structural business will be maybe gone or wrong something. So in my opinion, we rather than two direction, what I went is that one direction will do. Thing is, yeah, should be one direction. So from Tekla to Revit, then this would be great. Okay, so this is the workflow that I thought that it's suitable for the interoperability. Suitable for exchange information between the TSD and Revit. Then lastly, I want to mention is that, okay, for example, like in Revit, some points we need to drop the beam. Then what we need to do is, after settle it, we go and select the beam, and we purposely drop it. For example, this beam is not 850, right? So we have to create the same size in the other family. Currently is only one family or two family. Okay, we have this family there, so we have to rename it. This one to be like 850 by 750. Then this beam is, this one will be 850, drop 100, so 750. So if you want to change the size, then select, then this beam also select and change the size. Change the types. Then whatever drops, we have to adjust it manually, so we can adjust it from the plane. Then we will, okay, come to here. What we need to do is this one, drag it here, drag it to the edge. Maybe sometime we can align it. The best way is measure it. The value will be 1750, and this one should be 125, because not 125, column is now 350, so 125, 175, I think. So this one maybe 50, yeah. So we can do it that way. Here is the same thing. Just make it 4005 first. Yeah, then we have to drag it and apply it. Yeah, sometimes what we can do is we can align it sometimes. Yeah, then this one also same thing. We align it. Oh, then sometimes it's not really great to use align. So drag and yeah, then measure, but then put the exact value will be great. So now we have done this drop beam over here at one flow, right? So the rest flow, if same, what we need to do is we use match property to match Same thing over here. Okay, so looks great, but okay, this one is great. How come I think is this one something wrong, because just before what I did is that I aligned it, that's why things something wrong. Let me check on level 2. Then this should not be, supposed to be here. So okay, this one should be here. I think is this one will be 1600, I think. Okay, so no, this one to be here, right? Then yeah, so this one is supposed to be 4620, is it? Maybe this, and this value will be 1700, and then we can have the right position. So then we have to match again, and then we can have the right. But sometimes, okay, when we update the frame, then this beam will be gone again, no choice, because in TSD they only provide one beam family to be met, because in TSD also they don't have a two family type, two type, three type, like the rectangular one type, like a circular one type, something like that only. So that this is the kind of obstacle, kind of the limitation that we can't do much. We have to go manually and fix it out. Okay, yeah, that's all for this video, and I think it's next video I will explain about how to set up the Revit template file. Yeah, come to the conclusion. Yeah, it's actually we better plan or preparation more, then come to the downstream, our process will be more smooth. But somewhere something that some limitations are there, then if we can't cross over, then we have to face with the manual solution. And second thing is, as a modeler or as an engineer, we have to have more skill, not only on the one side, we have to have skill on the both sides as well. It would be great sometimes, you know, as a changing the size or adjusting the model, so structural modeler can do. If structural modeler can do in TSD, will be much more easier. It's like this kind of arrangement, so beam will be aligned to edge or center or something, because as an engineer they only think of the analytical line rather than the actual appearance. So if structural model involved into the structural analysis modeling process, then it will be great. So on the other side also, engineer knows about Revit, then it will be great as well. So they know not only the analysis process, they even know the Revit, like authoring and BIM production documentation parts also, then would be great. So we need more skill on the engineering and software usage as well. Then we need more collaboration, because after we finish some schedule, then this schedule will pass down to engineer. So when we pass down, we have to think of, okay, which way to choose. We will be using add-in tools like kind of I can remember some add-in tools can transfer Excel as a schedule to Excel, or maybe if we use Dynamo, then it will be easier also. So we have to have some kind of procedure that how we can collaborate to each other, then that will be great. So we need to have more collaboration process. Then finally, within the team, either design team or modeling teams or architectural teams, we try to remove any barrier, so that you like okay, you are the engineer, so you only need to know the engineering design software only. You don't need to know about the Revit or that kind of barrier. And even like the design modeler also, you are just modeler only, so you better don't touch my structural analysis. Yeah, sometimes some engineers may do that because they worry that something will be gone. So within the teams, we try to have more collaboration and more trust. Then we can remove some kind of barrier. Yeah, as of now, I think that's all I have. And thank you very much. If you have any question, you can comment down below, then I try to answer as much as I can if I know. If I don't know, then I will find out somewhere, then refer to there. Thank you for watching. Bye bye.